All right, hello everyone. Today we're going to talk about one of the most important tools that chemists can use. You see here I have some pictures of some glassware, very important tools for sure, but let's talk about something different. Scanning electron microscope. How about we talk about the Large Hadron Collider? How's that? That's a cool looking instrument for sure. It's in Geneva, Switzerland, and they use it to accelerate protons and smash them into each other. Very interesting, an amazing tool, but that's not what we're talking about today either. We're going to be talking about the periodic table. Woo! All scientists use the periodic table. It has a wealth of information that you don't even know about. There are secrets of the periodic table that I'm going to show you about today. So let's get started. Sweet. All right, so here's today's topic. It's about organizing the elements. We're going to first talk about how elements are organized on the periodic table. Then we'll take a look at early periodic tables and how they compare to modern ones. And then we'll talk about three broad classes of elements. Here we go. The periodic table is grouped according to similar properties. All elements in a particular group, all elements that are near each other, share similar properties. Very much like at the grocery store, how all the produce is in one section, all the dairy is in one section. Things are organized according to their properties. Same with the periodic table. J.W. Dobereiner in the early 1800s was the first person on record that tried to organize the elements. He did it by organizing them based on their similar properties. It wasn't until 1869 that the Russian chemist Dmitry Mendeleev arranged the elements according to atomic mass. Here is a photo of one of his first periodic tables back in the day. Notice how some of them have question marks next to them. That's because these elements weren't discovered yet, but when they were discovered, they'd fit exactly where he predicted they would fit. Look at numbers 68 and 70 there. Eventually, elements fit into there. It wasn't until 1913 that elements were arranged according to atomic number by Henry Moseley. Atomic number, that's how the periodic table is organized today. So there's two things we have to be aware of. Periods are the rows that go from left to right horizontally on the periodic table. We call those periods, and they correspond to principal energy levels. Then we have the groups, which run vertically up and down. These are columns where elements have similar properties. All elements within a group share similar properties, mostly because of their valence electrons. We'll learn about that in a little bit later. But for now, just understand that horizontally, the rows are called periods, and vertically up and down, they're called groups. Here we'll talk about the three broad classes of elements. We have metals, nonmetals, and metalloids. First, let's look at the metals. Here are some properties of metals. They conduct heat and electricity, which is why we use metals for things like copper wiring. They typically have high luster or sheen. They reflect light. They are mostly solids at room temperature, except for mercury, one exception there. They are ductile, meaning you can pull them into wires, which is how wires are formed. And they are malleable. They can be hammered into thin sheets or formed into pretty much anything you want by heating them up. This has been done for a really long time. Think about the ancient people who used to forge iron into weapons. Next are the nonmetals. The nonmetals, they are mostly gases at room temperature, except for a few of them, such as carbon, pictured here. They typically have opposite properties of metals. They are poor conductors of electricity or heat. Sometimes they're used as insulators, which is the opposite. They are brittle. They're not malleable. They're not ductile. You cannot form these nonmetals into weapons or whatever you need to form them into. They're too brittle. They will break apart. Metals will not break apart. Yeah. And then we have the metalloids. The metalloids have similar properties to both metals and nonmetals depending on the conditions that the scientists want. One typical example is silicon, which is used in computers. That is the classic metalloid. Scientists can manipulate the properties to get what they want. They can make them insulating or they can make them conducting. Okay, so now I'm going to show you something that is really, really important. Maybe one of the most important things we've learned in the past few months. I'm going to show you where the metals are on the periodic table and where the nonmetals are. You absolutely have to know this for when we start doing chemical bonding in the next unit, because what ends up happening is metals react with nonmetals. So you need to know what's what. I think the easiest way to do this is to know where the metalloids are, because the metalloids on the periodic table, they separate the nonmetals from the metals. So let's take a look at where the metalloids are. I'm going to draw a little staircase around the metalloids. They kind of look like a staircase because they go up and down. Okay, there's not that many of them. Again, here, I'm putting a box around all the metalloids. And then there's a couple of them down here. Okay, so up here in this upper corner are your nonmetals. There's not that many of them. Okay, to the right of the metalloid staircase. Everything else on the periodic table, all these guys, everything down here, even the actinoids, which got cut off on the screen here, these are all your metals. Metals. Clearly, the most abundant elements on the periodic table are metals. So you have to know these are metals, these are nonmetals, and they're divided by the metalloids right here. So just go from boron diagonally all the ways down to here, and a couple germanium, antimony. All right, metalloids, nonmetals, metals. Absolutely have to know this.